Hello students, in this video I am going to derive equations of motion by three methods: algebraically, graphically and by calculus. Let us start. Motion is the state of change in the position of an object with respect to time, and there are three equations of motion which describe the relationship between velocity, time, acceleration and displacement. For this, let us consider a body moving in a straight line with uniform acceleration. Let the initial velocity be represented by u, acceleration by a, time by t, final velocity by v and the distance travelled by s. Now these equations of motion can be derived by three methods, that is by simple algebra, by graphical method and by calculus method. Now let us derive by these methods one by one. Derivation of first equation of motion by algebra. So we know that the first equation of motion is v is equal to u plus at, where v, u, a and t are known to us. We know that the acceleration of the body is defined as the rate of change of velocity. So acceleration can be written as v minus u upon t. Simply by rearrangement of the terms, we will get v is equal to u plus at. That is first equation of motion, relationship between velocity and time. Now let us derive the second equation of motion by algebra. Second equation of motion is s is equal to ut plus half at square. The displacement is the product of average velocity and time. This we know. So the average velocity can be written as initial velocity plus final velocity divided by 2. Putting the value of final velocity from equation number 1, that is v is equal to u plus at, in the above equation, we will get this equation. Now simply by rearrangement of the terms, we will form second equation, that is s is equal to ut plus half at square. Now let us derive the third equation of motion. This equation will be derived with the help of first two equations. From first equation, we can calculate time like this: v minus u upon a. Now put this value of time in second equation of motion, that is we are eliminating t from second equation. We will form this equation, and by rearrangement of the terms, we will obtain the third equation of motion: v square is equal to u square plus 2as. That is velocity displacement relationship. Now let us derive the first equation of motion by graphical method. For this, consider an object moving along a straight line with uniform acceleration a. Here OA represents the initial velocity u, BC represents the final velocity v, and from the graph it is clear that the change in velocity is BC minus DC, which is equal to v minus u, that is this part. So acceleration can be written as change in velocity upon time taken. Change in velocity is BD and time taken is t. Cross multiplying, we get BD is equal to A into T. Putting down the value of BD from above equation, that is v minus u, we have obtained the first equation of motion as v is equal to u plus at. Now let us derive the second equation of motion. The area under the curve OABC is equal to the distance travelled. Look from the graph, OABC is a trapezium, and the area of the trapezium can be calculated by considering it in two parts. One is the rectangle OADC and the another is the right angled triangle ABD. So area of the rectangle can be calculated by multiplying length and breadth like this, OA into OC. And the area of the triangle can be calculated by half base into height, that is half AD into BD. OA and OC from the graph can be written as U multiplied by T, and for the triangle half base can be written as T and height BD can be written as change in velocity, that is V minus U. And this V minus U can be replaced by first equation of motion, that is V is equal to U plus AT. So from here we can write down V minus U is equal to AT like this. So we have obtained the second equation of motion as S is equal to UT plus half AT square. Now let us derive the third equation of motion. Again we will calculate the area under the curve OABC, that is equal to the distance travelled. Now we will calculate the area by using the area formula of trapezium. This is a trapezium OABC and the formula is half into sum of parallel sides multiplied by the distance between the parallel sides. Here the parallel sides are OA and BC. OA is represented as U and BC is represented as V. So sum of parallel sides can be written as U plus V. And the distance between the parallel side is represented by OC, that is T. So putting the value of OC like this. Now from first equation of motion we are aware that time can be calculated as V minus U upon A. Putting this value of time in above equation to eliminate this T, we will get this equation. Now simply rearrangement of the terms, you will get V square is equal to U square plus 2AS, that is third equation of motion. Now let us derive the equation of motion by calculus method. Let dv be the change in velocity, this is dv, in a time interval of dt. So acceleration can be written as rate of change of velocity, that is dv upon dt. Now cross multiplying, a dt is equal to dv. Now integrating both these sides and applying the limits of integration, we will get this equation, that is from 0 to t when velocity changes from u to v. So after integration we have obtained a into t and here we have obtained v. Then we will put the limits and finally we will obtain v is equal to u plus at. Now let us see the second equation of motion by calculus method. Let ds be the displacement of the object in time interval dt. This is ds in time interval dt. So we have written velocity as ds upon dt. Again v dt is equal to ds. Putting the value of v from first equation, v is equal to u plus at. We have obtained this equation. Now integrating both these sides and applying the limits of integration, that is from 0 to t that displacement is from 0 to s. After integrating, we will obtain ut plus half at square, and then we will apply the limits from 0 to t, and here it is s and limits are 0 to s. Putting down the limits, we have obtained s is equal to ut plus half at square. Now see the third equation of motion by calculus method. We are aware acceleration is equal to rate of change of velocity, that is dv by dt, and the above equation will not change if we multiply and divide by the same term, that is by ds in the numerator and dividing by the same term, that is ds. So now I am writing it in this manner that dv upon ds is together and this ds by dt is together. That means this ds by dt can be written as velocity v. Now rearranging the terms, a ds is equal to v dv. Now integrating both these sides within the limits from 0 to s, and velocity changes from u to v. After integration, we have obtained this equation. Now putting down the limits, we have obtained v square is equal to u square plus 2as. The advantage of using calculus method is that it can be used from non-uniform acceleration also. Thanks for watching. Please like, share and subscribe.